See. All right, let's say you were to rationalize. So you'll say, okay, I need to multiply that by, I need x squared plus the 4x. And then all of that is under the square root sign or the radical sign. The signs should be opposite now, plus the 2x. Yeah, and then all over, remember there's brackets here, you multiply, everything has brackets there, and then all over that. So we know this is in the brackets, that one there, that one there, that one there, and also the top. But sometimes we don't show it because we already know we are multiplying. But sometimes we don't show it, people miss the point. All right, so now next thing, we now have limit, and then as x approaches negative infinity. At the top, you know you must square the first. Am I right? The square root, the radical. So you'll be left with an x squared plus the 4x.
Yeah.
Then minus, you square the last one, so it's going to be minus the 4x squared. Am I correct?
Yes.
All right. Then at the bottom, I know it's like we're going to have two terms here. There'll be like two terms. Inside the parentheses, what I mean. Because we have the 2x outside multiplying. Let me see what have I got. Multiplying that radical side. Let me bracketize that one there. And I do that. Do you see that?
Yeah.
All right. Now, the question in your mind would be like, now, wait a minute. What is the highest x value in the denominator? You know what I'm trying to say? You understand what I'm saying? Yeah. So you're having a glitch. So you're going to have to pull out that. Let's fix the one at the top. The one at the top here, you've got like terms. What you got? You got x squared minus 4x. It's minus 3x, right?
Yeah.
All right. So it's minus 3x squared. So I just want to save space. All right. So let me cut that. And here. So we've got minus 3x squared. All right, so this one is good because it's beautiful. It's without the radical. Now, you do the same thing like how we did it before. Because look at it this way. What's under the square root? You've got an x squared. If I were to take square root somehow, even though it's two terms, that x squared will be reduced to x to the power of 1. Am I correct? Yeah. But let's just do that method I just showed you. So we now have limit, and then as x approaches negative infinity. All right, at the top, everything is set. Now we need to fix the bottom part under the square root because you really don't want to have that stuff there. So under the square root, you're going to pull out that x squared. All right, so I'm going to do it one time because you saw the process, because I'm still yet going to use that process again. This x squared would be the square root of x squared once it's outside the square root, correct?
Yes.
Or absolute value of x. But I need to choose whether to make it a plus or minus. Then it will be minus x because of that minus infinity. It will multiply this x here. So it means I have here, multiply by x here. But I can't do that yet. Why is that? Because I've got inside the brackets. Once it's outside, remember it's actually minus x there. And then you still have the parenthesis. So you can't take it out as common factor. Underneath there, we still have 1 plus 4 all over the x. It's because you had another term of plus 2x. So you need to consider that. When you pull out common factor here, that minus x, it also goes together with that 2x. Can you see what I'm saying?
Yeah.
All right. You understand what I'm saying? Because it must be common factor in both the terms.
Yes.
All right. Good. All right. So I can remove this rationalization part here. I just need space. Then we've got limit. And then as x approaches negative infinity, then numerator will never change. We still have negative 3x squared and then plus the 4x and then all over. Now remember the x is negative, so I can pull out as just x or negative. It doesn't matter how I pull it out. Okay, let me pull out as just the x. That means it's going to multiply that to 2x. Can you see that? Or I can multiply the 2x inside the bracket. Doesn't matter. Well, let's just multiply the 2x inside the bracket, which is what you like. I know you guys. So it's going to be minus 2x squared. And then we need the square root. Because it's next to the square, it's going to be square root of 1 plus 4 divided by x. The 2x must multiply that 2x. It's going to be a positive for x. Is that right?
Yes, for x squared.
Yeah, positive for x squared. Perfection. Now we can now check and say, oh, we need to divide everything by the x that has the highest denominator right at the bottom. All right, it has to be x squared. Can you see we're dividing top and bottom by x squared? Yeah. All right, so let me take the top one. I'm going to place it here and then divide everything by x squared. Divide here by x squared. Divide here by x squared. And now we need the denominator. And then we need to divide it by the x squared. So I'm bringing down there. So that means the x squared will go here with that one, because that is the term. It will also go with that one over there. So far, so good, right?
Yes.
All right, let's fix this one. This one, you'll be left with just minus 3x, correct? This one is 4 over the x, correct?
Yes.
All right, so I'm going to get rid of that. So you have that minus 3x. And then the other one you said is going to be 4 over the x, like that. All right. This one, you're going to be left with just minus 2, correct?
Yes.
All right, so we're getting rid of that. And then this one, you'll be left with just the 4, correct? Positive 4.
Yes.
All right, so we get rid of that. Good. Now it's time to give them the answer. So I'm going to write equals 2. So here's what we know. We know this is going to come to 0. This one will also come to 0. We good, right?
Yeah.
Now at the top, you now have negative 3. And then divided by. Now watch at the bottom, you've got negative 2 times the square root of 1. Well, it's going to be negative 2, then plus the 4. Can you see that?
It
When
gives
we-
you the same
it gives you the same answer. All right, there we go. Now, why did I do this? It's because sometimes the rationalization, when you're doing this, you cannot, because you wanted to separate the terms so that you can divide them by the x that has the highest degree at the bottom. Sometimes when you rationalize, it doesn't work very nicely. Then you say, oops, let me use the other method. Yeah. So I'm giving you two weapons now. I'm talking about this one for the limits, okay?
Yes.
Yeah.